So projectile motion, 2D motion, where only acceleration is gravity. In other words, what is the acceleration? The acceleration of the body, of the book, in this case, is 9.8 meters per second squared in the y direction. And again, I go back and forth between y hat and j hat. You can call it y hat, you can call it j hat, but that's the acceleration. So what does that mean for our 6 projectile motion equations? Right? We've got, 6 two-dimensional motion equations. Here are our 6 equations for two-dimensional motion. These are always true, 6 equations for two-dimensional motion. But if we're talking about projectile motion, then notice that a sub y is equal to 9.8 meters per second squared down. Again, we haven't, in general, defined up or down as positive, so we just have to say that. And a sub x is equal to what? What's a sub x equal to? Look at the acceleration. What's a sub x? 0. There is no acceleration in the horizontal direction. So what happens when you throw something horizontally? There's no, in projectile motion, right? If gravity is the only thing affecting you, if you throw something horizontally, sure, it falls and accelerates downwards at 9.8 meters per second squared, but in the horizontal direction, it's moving at constant velocity, right? Constant velocity in the horizontal direction. It only accelerates downwards. Whoops, why won't it write? Accelerates downwards. And so what that allows is that actually really simplifies these equations, because look at the so now the delta y. Let's call x horizontal and y vertical. It doesn't matter whether it's up or down, just in general. So we've got the first equation, the second equation, the third equation for the vertical direction. And in the horizontal direction, right now we're at the fourth equation, acceleration in the x direction is 0. So all we're left with is delta x equals v0 xt. And then we look at the fifth equation. Acceleration in the x direction is 0. So what are we left with? Vx equals v0x. What does that mean? What does that mean? That means constant velocity. The velocity at any time is equal to the initial velocity. That means constant velocity. Which, as long as we understand it's constant velocity, we don't even need to write down that equation. Let's look at the sixth equation. A sub x equals 0. So what are we left with? Vx equals v0x squared. Sorry, vx squared equals v0x squared. What does that tell us? Same thing. It tells us the velocity doesn't change, right? These two equations simply tell us the velocity doesn't change in the horizontal direction. So notice what we're left with is we're actually, for projectile motion, which is a special case of two-dimensional motion, we're left with 4 equations. And the first 3 are the standard 3 kinematic equations for the y direction. And the fourth equation is simply delta x equals v0 xt. And those are our 4 equations of projectile motion. So here are our 4 equations that describe projectile motion. Now remember, if it's general two-dimensional motion, it's not just gravity that's accelerating. There are 6 equations for two-dimensional motion, 9 equations for three-dimensional motion, but these are our 4 equations for projectile motion. Objects that are under the influence only of gravity, where y direction is vertical and x direction is horizontal. So let's go back to our question, where does the book land? So remember, we've got a building that's 30 meters high, and we throw it at 5 meters per second in the plus x direction. We've defined down as the plus y direction, so I'm not going to rewrite all this. But let's go ahead and just pretend we've already drawn our picture. We've already figured out it takes 2.47 seconds to land. And let's go ahead and try to, whoops, that was wrong. The next step is to write down what we know and what we don't know, right? Delta y equals plus 30 meters, because we defined down as the positive direction. A sub y is equal to plus 9.8 meters per second squared. I'm just going through our variables. Let me change my color, right? Delta y, a sub y. T, we know, is 2.47 seconds, because we've already figured that out. V0y is, what is V0y? The initial velocity of the book in the y direction. T, V0y we're about to write down. T is known. Okay. V0y is 0 because we're throwing it horizontally. Okay. Looking at the next line, V sub y. Do we know V sub y? What is V sub y? What is that? It's the final velocity in the y direction. That's the velocity just before it hits the ground in the y direction. That's unknown. V0y, we had already, I have to keep changing colors, sorry. V0y, okay, so we don't know this. V0y we know, A sub y we know, T we know. We don't know this. V0, okay, well, we've already done all these variables. And delta x. The next variable is delta x. That's we don't know, and that's what we're looking for. Right? Because I ask, where does it land? So we need to know how far away from the bottom of the building it lands. So delta x is unknown. V0x, what's V0x? V0x is equal to plus 5 meters per second. It's the velocity in the x direction. We defined the positive x direction, the direction that we were throwing it. And t is a known quantity. So we've just got a couple of additional variables. Let's see, 1, 2, 3, 4, 5, 6, 7. So instead of 5 variables and 3 equations, right, in one dimension, we had 5 variables and 3 equations. In projectile motion, we've got 7 variables and 4 equations, okay? And the connecting variable is time. Okay, so we want to know delta x. Oh, well, that was easy, right? So we've written all that down, and we can go ahead and plug in to the delta x equation. Delta x equals V0x plus 5 meters per second times time, 2.47 seconds. So delta x is 12.35 meters. So remember the question was, where does the book land? So we got to say more than just 12.35 meters. We got to say on the ground, 12.35 meters away from the building. Or 30 meters down, 12.35 meters out, right? So the book had gone down 30 meters and 12.35 meters out. And then you might say, well, don't I have to say, give this displacement vector? Well, we just don't care about the resultant displacement, right? It's going to go 12.35 meters out from the bottom of the building. This number here is not meaningful. I mean, it is meaningful. It's the distance that, it's not really, it's the displacement of the book. It's not even the distance of the book, right? Because the book is going to go parabolic. So it's actually going to go even a longer distance. So none of these distances matter. All we care about is 30 meters down, 12.35 meters out. So right. So the displacement, in that case, the component form actually makes more sense. It's easier to figure out where it lands if we talk about the component form. 30 in j, 12.35 meters I, 30j. Okay, so that's the answer to example 2.